Welcome back to another installment of the Bob Marshman series. Previously, we've talked in some depths about some of the key features of this building, particularly focusing on the passive house. I'd like to now concentrate on the range of other things that we've put into the building that make it so special, that make it a pathfinder. And I'll touch on those briefly, some of the things that we talked about previously with respect to its embodied carbon. So the carbon footprint of this building is very important to us. It was important during the design and also during the construction to make sure that basically its contribution to world greenhouse gases is kept as small as we could make it. So the overall carbon footprint of the building during the construction phase, as opposed to its carbon footprint now when it's operating, is 141,000 kilograms of CO2e. And what that means is CO2 equivalents. And it is a very low carbon building, and we want to talk today as we go through, we'll point out some of the features that actually make it so low in its carbon footprint. So in part two, we concentrated on the concrete. The concrete is about 45,000 kilograms of CO2e in terms of its embodied carbon. Because we bought carbon offsets for that, it is carbon zero, and that's very important in terms of its contribution to the overall carbon footprint of the building. So if we look at the bricks, for example, we mentioned the bricks briefly before, the bricks are about 5,000 kilograms of CO2e. And the lovely thing about the bricks is, big project, probably one of the largest infrastructure projects in Queensland for many years has been Cross River Rail. And these bricks have recycled content from Cross River Rail. So it really links us quite nicely to other big projects that are happening in Queensland at the same time. And the other large contribution to lowering our carbon footprint has been the plasterboard. So this plasterboard is once again about 5,000 kilograms of CO2e, and that is totally carbon zero. So carbon zero concrete, carbon zero plasterboard, carbon zero bricks. One of the nice features of the aesthetic here, the planter box, it's been designed in such a way to add to the neurodiversity of this building. So in terms of making ourselves available and comfortable for a range of people who might come here to learn, what we've put in here is certainly going to assist with that. When these plants are fully grown, they will be able to scavenge out any volatile organic compounds and other material that is actually maybe problematic in the indoor air quality. So we've got all of the stuff that we have dealing with making sure the indoor air quality is good, but we've got the addition of plants as well. This is one of our 5 training rooms, and they incorporate a number of the features that we want to discuss today. First element you will see is what looks like just a normal carpet tile that you would see in a particular room. The beauty of these carpet tiles is they're circular, so they're cradle to cradle. What we mean by that is they've been made from recycled fishing nets from the Philippines, and at the end of their life, they will go back into the process to make more carpet tiles. So zero additional diminishing resources from the earth have been used to actually make these carpet tiles. When we go to the windows, we've spoken about the windows before, but obviously the double glazed windows with the U value of 1.6, and that's very good at keeping the heat and the cold at bay. And further to that, behind the plasterboard here is the insulation. Double lots of insulation have gone in here, 160 millimeters deep with a R value of between 4 and 5, which is really, really good and significantly higher than you would get in, say, Section J of the Building Code of Australia. But I just want to mention, very hard to do through video, but just the ambient temperature in the room. It is just a very comfortable room with no mechanical heating or cooling. And the great advantage of that, particularly when we talk about the embodied carbon during its operational phase, like it is now, is that it's a very low energy building. We anticipate that the energy cost of this building is going to be something between 60 and 80% lower than its counterpart that isn't built to passive house standard. So that's a great advantage from an embodied carbon point of view, but the huge advantage in here is the fact that it's just a very pleasant and quiet environment in which to learn. Ever since COVID, And particularly with people working from home, indoor air quality has become much more front of mind. And each of our rooms has an indoor air quality monitor, and it's monitoring a range of conditions to make sure that the experience for the learners in here is as optimal as we can make it. But airborne pathogens are now, sadly, a feature of our everyday lives ever since COVID. And what we have within the ductwork that is reflected in the measurements of our indoor air quality monitor are a means to make sure that there is no build-up of bacteria, and we do that through UVC lighting and also through viruses. So there's no build-up of viruses in our system here, and that is through the use of ionizers. Both really leading edge things that are available now on the market that we've been able to put into the building as part of making it more than just a focus on passive house. We talked previously about the aluminium that was extruded to create the double glazed windows, but it's worth mentioning just briefly the green aluminium that's used internally here. So this is from a recycled aluminium billet using the Capral product, and it's their highest eco standard. So once again, a lower carbon footprint in just the elements that we're actually putting into the building. What do you do with your leftover concrete? Because you can never get it absolutely right in terms of volume. You make a bench top out of it. So this has been made by a fantastic company called 5 Mile Radius, some 3.7 miles down the road. So leftover concrete is made into bench tops. So this is some of the reuse and the recycling ethos that we had during the project. When we're building Bob Marshman building, we measured the amount of waste, construction and demolition waste, that came from doing this. And we're pleased to say that the amount of recycled material in making Bob Marshman came out at 92%. So we take all these elements together, the low embodied carbon and our concentration on some of these really exciting ideas that are starting to take hold now, like circularity. And we combine all of those and start thinking about carbon footprint, because carbon footprint is going to be so important to us in the future. It's really pleasing to note that you really need to calculate how much it contributed to global greenhouse gases through putting up a building like this. And like I said previously, it's quite a significant amount. So 142,000 kilograms of CO2 were created in us putting up this wonderful building, Bob Marshman building. But it's also very pleasing to say that because of the initiatives we've taken, like carbon offsets and the other things that we've been talking about over the range of these episodes, is the fact that this facility will be carbon neutral for its construction phase in mid-October 2024. When you build a building as innovative as the Bob Marshman building, it really starts to expand your horizons in terms of your thinking around the environment. And it wasn't too long before we thought, well, the students that are going to come to this building have to get here. What is the carbon footprint of the students who are coming to learn? And that's where the EV chargers came in. So we have 2 EV chargers, fast charging chargers from the company Tritium, and Tritium is a local Brisbane-based company, and that gives us 4 bays. So eventually, as utes start to become more popular, electric utes become more popular for the tradies who are the basis of our student numbers, the carbon footprint of the entire operation of the centre, including the building and also the people who come to the building, is going to get lower and lower. When considering building an environmental responsive building, it's the little things that will also contribute to the overall quite significant effort. And for example, we could have chosen timber. After all, we're using timber framing in the building, which we've talked about before, rather than structural steel, but we choose a composite to make our deck. And the beauty of that is the composite has significant amounts of recycled material in it that gives it, once again, its very low carbon footprint. And looking out across the drought-tolerant planting, So we need to think about every aspect of what our footprint is like on the planet. What can we do to actually conserve resources that are in scarce supply? And certainly water is one of them. They say it never rains in Queensland, but it sure as hell pours. So we have 3 10,000 litre tanks that we've installed to capture rain from the roof, harvest it and use it in our toilets for flushing. And that is making sure that we have a really low demand placed on our scarce water resources. And then we have our solar inverters. So we have 128 solar panels on the roof generating 55 kilowatts. And that is enough, as calculated, to cover the demand that this building makes in terms of the electrical consumption. Now that electrical consumption, of course, is quite low because we're not using traditional heating or cooling, air conditioning to actually make the building comfortable. The building is made comfortable, as you will know by now, by the membrane, the double glazing, the air tightness. And as a result, this building is able to look after itself. So from an ongoing operational carbon footprint point of view, we anticipate this will be a very, very low carbon footprint building. And it's all those elements put together that make this such an exciting building, make it a pathfinder. And really, one of the reasons why buildings like this need to be a feature of the way we build now and into the future.